Now we'll discuss the associative property. This is called the associative property that we are going to discuss. Okay. Associative property, we'll discuss in both or and and. So now instead of two paths, there are three paths to go from A to B. There are three paths to go from A to B. One is X, another is Y, another is Z. These are all three are optional in OR. So in AND, there is path from this point to this point X. There is a path from this point to this point Y, and there is a path from this point to this point Z. Okay. So all the paths are compulsory in AND, and all the paths are optional in OR. Okay. So you want to know which of the pairs will be resolved first. If we want to, if we can check just pairwise, that between Y and Z there is a path from A to B, and then we want to check that whatever the result was, so between Y and Z there is a path from A to B, and we want to check with X together, so we will know that there is a path from A to B. And if between Y and Z there is no path from A to B, so depending on that we will check X, that X has or does not have path from A to B. So there can be an order to resolving these variables. Okay. So there is an order to resolving these variables. So Y and Z can be resolved first. So we might check whether there is a path in either of these two, and then we might resolve X, that there is a path in X or not. Or the ordering might be different, that there is a path to go from A to B within X and Y, or there is not, and then we'll resolve Z. Okay. Now do you think which one we resolve does matter? Are both these values equal? So it does not matter, right? Whether you resolve Y or 0 to Y and Z together and then resolve X, or you resolve X and Y together and resolve Z, does not matter, because whether there is a path from A to B depends on all of X and Y and Z, and it is like X, Y and Z all are options. All three are equally important, and all three are optionals. So if any of them have a path from A to B, then there is a path from A to B. If two of them have a path from A to B, then there is a path from A to B. If all of them have a path from A to B, then there is a path from A to B. If none of them have a path from A to B, if all of them are blocked, then there is no path from A to B and the road is blocked. Simple, there is no ordering. So which one you resolve does not matter here, because all of them have the same weightage or importance. Here also. X might be blocked, Y might be blocked, Z might be blocked. Okay. So if you resolve X and Y first, okay, does not matter. If any one of them are blocked, then the road is blocked. If any two of them are blocked, then the road is blocked, you cannot go from A to B. If all of them are blocked, then the road is blocked, you cannot go from A to B. Only when all of the roads are free, X, Y and Z, all of the roads are free, then the road is free and you can go from A to B. So again the ordering should not matter here, and which one you resolve first does not matter here because all of them are equally important, have equal priority. So if any of them are blocked, your road is blocked. If two of them are blocked, your road is blocked. If all of them are blocked, your road is blocked. If all of them are free, your road is free. Here, if any of them is free, the road is free. If two of them are free, the road is free. If all of them are free, then the road is free. Right? And you can go from A to B. And if none of them are free, all of them are blocked, then there is no road from A to B. The road is blocked. Right? This is the associativity operator.